right, we're going to start tonight with Lesson 13, Module 3. I can use multiplication, addition, or subtraction to solve multi-step word problems. So let's get started. Using the read, draw, and write method, we are going to answer the following word problem. Over the summer, Kate earned $180 each week for 7 weeks. Of that money, she spent $375 on a new computer and $137 on new clothes. How much money did she have left? All right, so we are going to be using the read, draw, and write method. So we just read it, but we need to read it again and find those important words and phrases that will help us understand and solve this problem. So over the summer, Kate earned $180 each week for 7 weeks. Of that money, she spent, there's that word spent, $375 on a new computer. So when we hear the word spent, we know that we're going to be doing taking away. And then she spent $137 on new clothes. So again, there's that other way we're going to be subtracting from that money. How much money did she have left? Again, that is a form of subtraction. So we know that we are going to be subtracting somewhere in this problem. So let's start figuring this out by step and go back, and she earned $180 each week for 7 weeks. So this part is going to be our first part of the word problem. So let's draw that out and show a tape diagram. So let this box represent $180 because that's what she had for the first week. That's how much she made for the first week. But she did it for 7 weeks, so we need to make these 6 boxes. So we have 1, 2, 3, 4, 5, 6, 7. And each and one of these is $180. Because that is how much she made each week. But she worked for 7 weeks. So all of this total we need to figure out. And how we're going to figure out that? Instead of doing 180 and repeated addition over and over, we're going to use the shortcut and we are going to multiply by 7. So 180 times 7. Now you could use the standard algorithm, the partial product, or the area to help you solve. I am going to choose to do the standard. So in the ones, it's a 0. So 0 times 7 is just 0. In the tens, there's an 8. 8 times 7 is 56. So I put the 6, I carry the 5. In the hundreds, we have a 1. 1 times 7 is 7, plus the 5 is 12. So Kate earned $1,260 for 7 weeks. All right, so I just did the RDW process for the first step of this word problem. I still need to figure out how much money she spent and how much money she has left from this total. So we still have a lot more left to do. All right, continuing with the RDW method. We already used it to solve step 1 of this multi-step word problem. We already figured out how much money she earned in 7 weeks, and that's right here, $1,260. But then she kept spending money on a new computer for $375, and then she spent $137 on some new clothes. So we need to find the total of how much money she spent. So she spent $137 on a new computer, and she spent $137 on clothes, and then she spent $375 on a computer. So what was the total cost of how much money she spent? Well, we need to add. So we have $375 plus $137, and we get 12. Carry the 1, 8, 11. Carry the 1. 1 plus 3 is 4, plus 1 is 5. So she spent $512 on a computer and a new clothes. But now it's asking, from this amount of money that she earned over that 7 weeks during that summer, she spent $512. So we need to know how much money she has left. So when we say have left, how much money does she have left? Because she spent it, we know we're going to be subtracting. So if we did our tape diagram, over here is her total amount of money, $1,260. And from that, she spent $512. I need to know how much money does she have left. This part is going to show me how much money she has left. So we're going to subtract. $1,260, take away 512. Well, we can't solve the 1, so we can go in the tens and take 1 away, and that's left with a 5, and this becomes 10 ones. 10 minus 2 is 8, and in the tens, we have 5 tens, take away 1 10, and we are left with 4 tens. Then over here, we can't do the hundreds, 2 minus 5, so we have to take 1,000 away. We're left with none, and now we have a 12. 12 in the hundreds, 12 take away 5 is 7. So she is left, Kate is left with $748. So now we need to do the W part. Kate has $748 left. All right, we need to keep persevering, pushing along. These problems are many. We just finished a 3-step word problem, and now we're on to another big one. So don't give up, keep trying, and do your best. Sylvia weighed 8 pounds when she was born, and now we're going to follow the read, draw, and write process for solving this problem. So first we need to read. Sylvia weighed 8 pounds when she was born. By her first birthday, her weight had tripled. By her second birthday, she had gained 12 more pounds. At that time, Sylvia's father weighed 5 times as much as she did. What was Sylvia and her dad's combined weight? Wow. So this is a lot of information in here. So let's keep persevering along. Sylvia weighed 8 pounds when she was born. But by her first birthday, her weight had tripled. What does that word tripled mean? Well, we're going to be multiplying by 3. Again, it's like that multiplicative comparison. 3 times as many, 2 times as many. By her second birthday, she gained 12 more pounds. At that time, Sylvia's father weighed 5 times as much. There's that multiplicative comparison. Now, the main question is Sylvia and her dad. What is the combined weight? And when we hear the word combined, we're going to be adding. So when we hear 5 times as much, that's our multiplication. Tripled, and we're multiplying. And over here it says she gained 12 more. Just 12 more. We're not making a multiplicative comparison. We're going to be adding this one. So let's get started with the first step. Sylvia weighed 8 pounds when she was born. By her first birthday, her weight had tripled. Okay, so she was 8 pounds when she was born, but then her weight tripled. So 2, 3, because it's basically saying 3 times. So 8 and 8. So we got 3 groups of 8. And the total of this, by her first birthday, 3 times 8 is 24 pounds. So by her first birthday, she weighed 24 pounds. But then the second part is by her second birthday, she gained 12 more pounds. So now if we had another tape, this represents 24. And by her second birthday, she's got 24. But now we have to add 12 more pounds. So how much does she weigh by her second birthday? Well, we're just by showing 12 more, and over here in our tape diagram, we're just adding on 12 more pounds. So now we need to add 24 plus 12 would be 36 pounds. So by her second birthday, she weighed 36 pounds. All right, so now we just solved 2 steps already. We multiplied by 3 to get 24 pounds by her second birthday. And then, at her second birthday, she gained 12 more, and then we had to add to that. And then we got, so by her second birthday, right now, she's 2 years old, she weighs 36 pounds. But now if we continue to read, Sylvia's father weighed 5 times as much as she did. So now we need to find out if Sylvia, with a tape diagram, if she weighs 36 and her father weighed 5 times as much. Well, we need to show that. 1, 2, 3, 4, 5. 36, 36. So we have 5 groups of 36. So we have to figure out what that is. What is the total here? Well, that is 36 times 5. And in the 1, 6 times 5 is 30. 0, carry the 3. 3 times 5 is 15, plus that 3 is 18. So her father weighs 180 pounds. But we're not done. We have our last step that we need to focus on, and we have that word combined weight. And when we hear the word combining, we're taking some things and we're putting them together. So that means we're going to add. So if her father weighed 180 pounds and she weighed 36 pounds, we're going to add these up and get 6. 8 plus 3 is 11. Put the 1, carry the 2. Carry the 1. 1 plus 1 is 2. So they both weigh together 216 pounds. So now we need to write that out. The combined weight is 216 pounds. Wow. Was that a hefty word problem? But we persevered through it, step by step. All right, 3 boxes weighing 128 pounds each, and 1 box weighing 254 pounds were loaded onto the back of the empty truck. A crate of apples was then loaded onto the same truck. If the total weight loaded onto the truck was 2,000 pounds, how much did the crate of apples weigh? So we're going to follow that read, draw, write process to solve this word problem. And we're going to focus on the reading part. And when we're reading, we are looking for those important words and numbers to help us solve and understand how to solve this word problem. So there are 3 boxes, and they're weighing 128 pounds each. And then there's 1 box weighing 254 pounds. And then they say a crate of apples was then loaded, but they don't give us the number for that. And they're giving us the total weight of 2,000 pounds. So 3 boxes weighing 128 pounds each, and 1 of them weighing 254 pounds, were loaded onto the back of an empty truck. A crate of apples was unloaded onto the same truck, and they're giving us the combined weight of 2,000 pounds. All right, so now that we did the read part, let's do the draw part, and let's make a tape diagram. 3 boxes weighing 128 pounds each. Right there is showing us that multiplication. So let's draw 3 boxes. 1, 2, 3, and that's 128 pounds in there. Okay, and then there's another box that weighs 254. All right, so then we know that there's a big apples, but we don't know how much that one is. But we do know all of this, all this weight, all these pounds is going to equal 2,000 pounds. So let's solve this, because over here we do not know 3 groups of 128 is. So 128 times 3, 8 times 3 is 24, put the 4, carry the 2. 2 times 3 is 6, plus 2 is 8. 1 times 3 is 3, that's 3. So 384. So this tape is equal to 384 pounds. But then we also now have 254 pounds. So what is this part combined? So we need to add that up. 384 plus 254, that's 8. 8 plus 5 is 13. 3, carry the 1. 3 plus 2 is 5, plus this 1 is 6. So this is 638 pounds. Well, that's basically saying 638 plus apples is equal to 2,000 pounds. How do we solve for A, the missing variable, that missing number? Well, this is saying to add, so we would do the inverse operation, and the inverse operation of addition is subtraction. So we would take 2,000 minus 638. So we're subtracting across zeros. So we need to go all the way to the thousands and take 1 away from him. Make this a 10, but we're going to have to take another 1 from that because it's not going. This becomes a 9, this one becomes a 9, and this one becomes a 10. 10 minus 8 is 2, 9 minus 3 is 6, 9 minus 6 is 3, and we're left with 1,000. So how much did the apples weigh? It weighed 1,362 pounds. So we need to write that out. The apple crate weighed 1,362 pounds. Wow, we did a lot of steps here to solve for this problem. Guys, we need to take it step by step and look at each line by line to help you solve for this problem and for the future problems. Don't give up. Keep trying. Let's persevere. Give it your best. Okay, this problem is split up into 3 parts. And you're going to be using the read, draw, write process. So this part 1 is Michael earns $9 per hour. He works 28 hours each week. How much does he earn in 6 weeks? Then the part 2 is David earns $8 per hour. He works 40 hours each week. How much does he earn in 6 weeks? And then in the third part, it's after 6 weeks, who earned more money? And it's asking you how much more. Guys, there's a lot of steps in each of these 3 problems. So what I'm going to do is I'm going to break it down, and I'm going to ask 3 individual questions to solve for this. Okay, so that first part, Michael earns $9 per hour. He works 28 hours each week. How much does he earn in 6 weeks? Use the RDW process to solve for that. That second problem. David earns $8 per hour. He works 40 hours each week. How much does he earn in 6 weeks? Use the RDW process to help. And the third step to that word problem. After 6 weeks, who earned more money? How much more money? There's that key. Much more. Okay, last problem. Computer Depot sold 762 reams of paper. Paper Pals sold 3 times as much paper as Computer Depot, and 143 reams more than Office Supply Central. How many reams of paper were sold by all 3 stores combined? Victory is mine! You guys persevered. Good job. Try to see if you can bring in some of those tape diagrams that you worked on to solve these problems tonight. Wonderful persevering. I'm proud of you. Have a wonderful night.